There is a category of mining machine that has been in continuous development for longer than the diesel engine has existed, longer than the automobile, longer than powered flight. A technology that was already mature and productive before the First World War, that survived the introduction of diesel power without being displaced, that survived the rise of hydraulic excavators without retreating from the hardest applications, and that continues today, after more than a century of continuous refinement, to be the dominant technology in the most demanding surface mining environments. This is the electric rope shovel, and its finest current expression, the machine that represents the absolute state of the art, is the P&H 4100XPC, the largest electric rope shovel currently in production anywhere in the world. Most people have never heard of P&H mining equipment. The company's origins trace to the Harnischfeger Corporation, a Milwaukee engineering firm founded in 1884 that built cranes, hoists, and eventually electric shovels. The machines became the workhorses of American surface coal and copper mining for generations. The P&H name became synonymous with electric rope shovels. The machines were so reliable, so productive, and so dominant in their applications that P&H became the default reference point for the industry. Today, P&H mining equipment operates as part of Komatsu, following an acquisition that brought one of the oldest names into the world's largest manufacturer. But the engineering heritage is intact. The 4100XPC is a direct descendant of the electric shovels P&H was building in the early 20th century. It remains consistent in its fundamental architecture, its operating principle, and its engineering philosophy, refined over a century of hard rock mining experience. This philosophy is what makes the 4100XPC different from every hydraulic excavator. Not different in size, but in how it achieves that productivity. Different in the specific conditions where it excels, and different in the maintenance characteristics that define its total cost of ownership. But before we get into what makes the 4100XPC extraordinary, before the dipper capacity and electric drive system, we need to understand the operation. The fundamental principle of rope shovel operation is genuinely different. Once you understand it, the century of dominance makes complete sense. The way it engages rock and fills its dipper is mechanically superior for hard rock. This is why the technology has survived and thrived for over 100 years. In exactly the environments where you might expect modern hydraulic technology to have displaced it, the electric rope shovel remains the king. A rope shovel, also called an electric rope shovel, operates through a system of cables, drums, and a dipper handle, rather than hydraulic cylinders. The dipper, the bucket equivalent, is mounted on a handle that protrudes forward from the machine's boom at an angle. The handle can slide in and out along the boom saddle block, extending to crowd the dipper into the face, or retracting to pull it back. The dipper is raised and lowered by hoist cables running over the boom's sheaves, driven by electric motors and drum systems in the main house. The machine positions with the boom facing the working face. The dipper is lowered to the base of the face. The crowd motion extends the handle, driving the dipper teeth into the rock. Simultaneously, the hoist motion lifts the dipper upward through the face. The combination of the crowd force pushing and the hoist force pulling upward fills the dipper with material torn from the face. When the dipper clears the top, the swing motion rotates the machine to position the loaded dipper over the truck. The dipper door, a hinged door at the bottom, opens and the material falls into the truck bed. The door closes. This sequence is the same fundamental sequence that electric rope shovels have been performing for over a century. Now here is why this sequence is particularly effective in hard, competent rock. The hoist system can generate enormous forces. The electric motors in the 4100XPC are large AC units, producing a combined hoist force that can lift through rock that would stop hydraulic sticks. The structural simplicity of the rope drive, no hydraulic cylinders or hoses subject to impact damage, makes it inherently more robust. In very hard rock, repeated impacts cause fatigue damage in hydraulic excavators. The rope shovel has no hydraulic cylinders in its working arm. The rope drive absorbs impact loads through the elasticity of the wire ropes. The ropes stretch slightly under impact and then return, damping the shock. While the Bucyrus RH400 has a larger bucket, the 4100XPC competes because bucket capacity is not the only metric. Cycle time and fill factor matter. In hard rock, the rope shovel's fill factor is often higher because its hoist geometry allows it to load coarser material more completely. The decision is about which machine delivers the best cost per ton in the specific conditions of the specific mine. The electric drive system has efficiency and reliability characteristics that no hydraulic system can match, making it the dominant choice in its applications. The P&H 4100XPC runs entirely on electricity. There is no diesel engine on board, no fuel tank, no cooling system for an internal combustion engine, no exhaust. The machine is connected to the mine's electrical grid by a trailing cable, a heavy, specially engineered cable. That pays out and reels in as the machine moves, keeping it continuously connected to its power source. This is a fundamental difference from every other machine we have discussed in this series. The 797F, the T282C, the 980E, all diesel-electric, carrying their own power generation on board in the form of diesel engines driving generators. The 4100XPC carries no power generation. It consumes grid electricity directly, and this difference has profound implications for the machine's operational characteristics, its environmental footprint, and its total cost of ownership. The electric motors that drive the hoist, crowd, swing, and propel functions are AC motors controlled by variable frequency drives. Variable frequency drive technology allows precise, smooth control of motor speed and torque across the full operating range, from the slow, high-torque conditions of the initial crowd into the face to the high-speed swing motion between the face and the truck. The same technology is used in the traction motors of modern electric locomotives and in the propulsion systems of large ships. In the 4100XPC, it is applied with decades of refinement specific to the demands of hard rock mining operation. The AC electric motors have no moving parts that wear in the way mechanical components do. No brushes, no commutators. The rotor spins inside the stator without contact between them. The forced transmission is entirely magnetic. The primary wear items are the bearings. Their replacement is a planned maintenance event, not an unplanned hydraulic failure. The hoist system, the drums, ropes, sheaves, and drive motors, is the most mechanically complex element of the 4100XPC. The wire ropes are subject to continuous cyclic bending as they pass over the boom sheaves, requiring periodic rope replacement. Rope inspection, using visual examination and magnetic flux leakage testing, is a routine maintenance discipline. The dipper, the steel container that holds the material, is a consumable item with wear components requiring regular replacement. The dipper teeth wear down with use and must be replaced on a schedule determined by material hardness. Managing dipper wear is part of the operational discipline that maximizes productive utilization of the machine. The propel system, the crawler drive, moves slowly and deliberately. Most of its time is spent stationary, working the face. The absence of a diesel engine eliminates an entire category of maintenance requirements like oil changes and fuel filter replacements. The AC drive's superior controllability produced faster cycle times and better efficiency, reducing energy consumption per ton. The transition from DC to AC drive was a step change. The 4100XPC delivers that performance as its baseline. The P&H 4100XPC is deployed in the copper porphyry mines of South America, the high-altitude hard rock operations in Chile, Peru, and adjacent countries that produce a substantial fraction of the world's copper supply. At mines like Codelco's Chuquicamata and Escondida in Chile, 4100XPC units work in rock whose compressive strength approaches or exceeds the hardest materials that hydraulic excavators can reliably handle. The rope shovel's structural robustness, its ability to absorb dipper impacts with hard rock fragments without the fatigue damage consequences that challenge hydraulic stick cylinders, makes it the preferred loading tool in these conditions. At Bingham Canyon in Utah, the largest copper mine in the United States, and a mine in continuous operation since 1906, electric rope shovels have been working from virtually the beginning. The technology has evolved enormously over that century. The machines have grown from small units to the 4100XPC's 61 cubic meter dipper. Control systems have evolved from manual to electronic automation. The drive systems have evolved from DC to AC. But the fundamental operating principle, electric-powered, rope-driven, has been continuous. At Bingham Canyon, a single mine has witnessed the complete development history of the electric rope shovel. And at each generation, the rope shovel has remained the primary loading tool, showing the technology's enduring suitability for this application. In coal mining, the 4100XPC competes with hydraulic excavators in a market where the rock is softer, but the production volumes are enormous. In Wyoming's Powder River Basin, the world's largest coal-producing region, rope shovels and hydraulic excavators work side by side. The softer material makes the hydraulic excavator's crowd force advantage less critical. The scale makes the rope shovel's large dipper capacity attractive. Established maintenance infrastructure for electric rope shovels reduces operational risk compared to newer markets where that infrastructure must be built from scratch. The Australian iron ore operations of the Pilbara have adopted a mix of rope shovels and hydraulic excavators reflecting specific material conditions. In the hardest banded iron formations, rope shovels are preferred. In softer material, hydraulic excavators are chosen for operational flexibility. Mining engineers making these decisions do detailed cost-per-ton analysis. Both technologies maintain permanent places in the Pilbara's equipment fleet. The economic performance of the 4100XPC in hard rock applications consistently validates its position at the top of the loading equipment hierarchy. In operations where material hardness and bench geometry favor rope shovel technology, the 4100XPC delivers results that hydraulic alternatives cannot match. The combination of large dipper capacity, high fill factor, and fast cycle times enabled by the AC electric drive produces sustained high output. This productivity and cost profile is, in the right conditions, simply better than any available alternative. The P&H 4100XPC represents the current pinnacle of a technology that has been in continuous development for over a century. The machines that Harnischfeger was building in the early 20th century would be unrecognizable to an engineer looking at a 4100XPC today. The components, the materials, the control systems, the drive technology, all completely transformed. But the operating principle remains the same. Electric power applied through a rope drive is the most effective way to move a dipper through hard rock. Most technologies are eventually surpassed. The steam engine was surpassed by diesel. The mechanical transmission by diesel-electric in ultra-class haul trucks. But the electric rope shovel has not been surpassed in hard rock mining. It has been refined and optimized, keeping its fundamental superiority intact. The future will be shaped by automation. The development of autonomously operating rope shovels that do not require onboard operators is a key focus. The 4100XPC platform is compatible with autonomous control technology that Komatsu is developing, moving toward a standard of driverless operation. This machine is already fully electric. It produces no direct emissions on site, with an environmental footprint that decreases as the grid decarbonizes. Komatsu's ongoing development will continue incremental improvements, punctuated by step-change innovations in power electronics and structural materials. When the rock is hard and sustained high output is the metric that matters, the rope shovel wins. It has won for 100 years. Watch a 4100XPC at work in the copper mines of Chile. The machine crowds into the face. The dipper enters the rock at the base. The hoist pulls upward. The hard porphyry copper ore yields, coming out of the face in a continuous flow of fragments. The dipper clears the bench. The machine swings. The dipper door opens. The material falls into the truck bed. That is a century of engineering expressed in 30 seconds of work. The oldest technology is still the best tool for the hardest jobs. Next, we move to the Sandvik DR416i, a machine that doesn't dig but drills to the precise depth required by blasting engineers. The largest rotary drill in common use, its precision determines the quality of every blast and the efficiency of every step that follows.